In this project, we ask if objects made of plastic materials can be connected to the internet without the need for batteries or electronics. We propose two complementary methods involving conductive and ferromagnetic filament. Printed Wi-Fi allows 3D printed plastic objects to send data wirelessly to any Wi-Fi receiver. Using ambient Wi-Fi from any Wi-Fi router, our 3D printed devices either absorb or reflect the Wi-Fi signal to convey a 0 or a 1. A Wi-Fi receiver like a smartphone or tablet will receive a backscattered signal that can be decoded to reveal a set of bits. At the core of our design is a backscatter switch, which is attached to a spring. A circular plastic gear containing a code presses against the spring, which makes contact with the 3D printed antenna made of conductive filament. When the switch makes contact with the antenna, the ambient Wi-Fi signal transitions quickly in amplitude. We can encode a binary code using the presence or absence of a gear tooth. Similarly, we can use the width of gear teeth to encode information. We build on this backscatter design to create a set of wireless sensors, smart objects, and input widgets without any batteries or electronics. We create an anemometer to measure wind speed. Here we see the raw time domain signal. Note the transitions as the backscatter gear rotates. We also create a flow meter to measure water speed. Using a rack and pinion gear setup, we create a wireless scale that can measure different weights. Building off these sensors, we create two smart objects. Here is a detergent bottle instrumented with a bolt-on flow meter. A smartphone app can be used to order refills when the amount of detergent runs low. This smart test tube rack can be used for inventory tracking by indicating the presence of a test tube and the amount of liquid it contains. We also construct 3 input widgets, including a button, knob, and slider. Our second technique leverages ferromagnetic plastic to embed data into 3D printed objects like a magnetic disk. All embedded data can be decoded by swiping a smartphone's magnetometer across an object surface. Data can be embedded on straight or rounded surfaces, like this pair of eyeglasses and this armband. We use a segment of ferromagnetic plastic to encode a 1 and a segment of plastic to encode a 0. Our objects can be decoded by hand or automatically by a robot. We can also encode bits into existing 3D digital models by slicing up the STL file and assigning materials for different segments. Here we encode bits into a teapot, octopus, and vase. With these techniques, we enable a rich ecosystem of talking objects, thus democratizing the vision of ubiquitous connectivity.